potential energy, everything, so that at point A, B, C and then D. Can you tell me the velocities? Yes, VC, root GR. Then this is root 3 GR. And then here root 5 GR. And again root 3 GR. This is about the velocity. And also we have seen the tension. Tension T at this point is how much? 0, approximately 0 Tc. And here Td is equals to 3 mg. I said that for the tension what you have to do? Plus 3 you have to do. And then at A what is that? 6 mg. And here how much again? 3 mg. This is about the tension we have seen. And after that we have derived the formulas at the point P. What is the velocity at point P? V is equals to, what is the formula we got? I said that at point A how much is there? Root 5 GR is there. No? That 5 GR will be get splitted as what? 3 and 2. Madam, look at the board. 3 and 2. It will be get splitted as what? 3 and 2. For 2 what will come? Cos theta will come. So that V is equals to under root 3 GR plus 2 GR cos theta. And what about the tension? I'm sorry, root is not there. 3 mg plus 3 mg cos theta. This is the tension at point P. And also whenever you see after the velocity and then tension, what we have discussed next? Potential energy, I guess. What is the potential energy? U at the point A is how much? 0. Why? Because this is 0 level, right? Then after that here potential energy will be how much? Mg into, what is the height here? R is the height, otherwise L is the height. Anything is correct only. Now here what is the potential energy? 2 mgr. Very good. What about the here? Mgr again. This is about the potential energy we have seen. After that we have discussed the centripetal acceleration or radial acceleration. Radial acceleration, what is the formula? V square by R only, right? So that here radial acceleration AC is equals to what it will be? 5g, just 5g. Why? Because V square nothing but 5gr divided by R. R gets cancelled, 5g will be remaining. Here radial acceleration is how much? 3g. Here radial acceleration is how much? Just g. And then here radial acceleration is 3g again. This is what radial acceleration we have discussed. Next after that we have discussed the tangential acceleration. Tangential acceleration at this point is how much? 0. At this point g. And here 0. And then here also g we will get. Whenever it is there, the centripetal acceleration or centrifugal acceleration is there in the direction of mg or opposite direction of mg, at that time we will get how much? 0 as a tangential acceleration. Next, whenever the centripetal acceleration is, centrifugal acceleration is there in this direction, tension is there in this direction, mg is there in extra downward direction, that will be the tangential acceleration. That is how much? At is equals to g we got. And also we got this everything at the point P also. What is that potential energy at point P? What will we get? U is equals to mgl into 1 minus cos theta. This is what the potential energy we got. And after that we have seen the AC. AC is equals to what will we get? G sin theta. Na? AC. AT is G sin theta. AC is what? Just 3gr plus, not R is not there, 3g plus 2g cos theta. This is what AC will get. Why? Because V square by R is the formula for us. Next AT is equals to, this one is separate, that is G sin theta. That is what we have seen yesterday. Will you write in one circle only everything? What happened? Near Uday. Everything try to write without seeing. Don't copy that. Just write without seeing. If any mistake is there, then you can check and then you can correct it. Write without seeing, I said. Don't look at the board. I will rub the board otherwise. Don't look at the board, nothing but don't look at the notes and then write. Yesterday's table is there, no? And says, ಏನಂತ ಇದ್ರು ಫ್ಯಾನ್ಸ್ ಎಲ್ಲರೂ? ಯಾವುದು? ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಆಕ್ಸಲರೇಷನ್, ನೆಟ್ ಆಕ್ಸಲರೇಷನ್ ತೊಗೋಬೇಕಷ್ಟೆ. ಅಟ್ ಪಾಯಿಂಟ್ ಬಿ we got the centrifugal acceleration in this direction, right? And also here we got the tension. In this direction, what is there for us? mg sin theta will be there, no, obviously. So that this is the AC, this will be the AT, that's it, g sin theta. Finished? Yesterday I said, no, how g sin theta will come? Did I explain or not yesterday? I did not explain, I guess. So, at any point P, let me take point P here. Everything we got at point P, what is the velocity we got? Under root 3gl plus 2gl cos theta we got. So, in the same way here, whenever at point P the particle is there, it was making how much angle with vertical? Theta with the initial position. And also now, here centrifugal force is acting in this direction. Centrifugal force nothing but what I can take? M into AC I can take. Mass into centripetal acceleration only, na? F is equals to ma. Then, and also here what is there for us downwards? mg is there. This angle is how much? Theta means this is mg, this is theta, this direction what will you get? mg cos theta, right? Are you listening? Down mg is there. Next angle is theta, nothing but next adjacent side will be what? mg cos theta. And this direction what will you get? mg sin theta. Now if we draw the free body diagram alone again, now in this direction we are getting what? fc plus mg cos theta, fc plus mg cos theta. And also in this direction what we are getting? mg sin theta. Now this will be the radial acceleration. AC at the point is how much? 3g plus 2g cos theta. If we solve this one, fc is equals to what is the formula? mv square by r. mv square by r nothing but what will you get here? 3g plus 2g cos theta. 3g plus 2g cos theta. This entirely is what? Nothing but radial acceleration AC. And the remaining one is what? Automatically AT only, right? Then where you will get the resultant? This is the net acceleration you will get. Understand or not? So along the AT what is there for us? G sin theta. Along the AT G sin theta is there, so that AT is equals to what here? G sin theta. AC is equals to what here? 3g plus 2g cos theta. Understand, right? How it came? So generally whenever you see this point, at this point the centrifugal acceleration will be there radially outwards, that is fc is equals to m into AC. Now if you take the components of mg is there in the downward direction. Along the fc mg cos theta is there, opposite to that mg sin theta is there. Now this entirely will give the radial acceleration, this will give the tangential acceleration, then middle one will give what? Net acceleration. What is the net acceleration there? Under root AC square plus AT square we will get. So that along the tangential acceleration what is there for us? G sin theta is there, so that only AT is G sin theta here. Understand, right? Yes. And also yesterday I said that whenever the particle is not able to cross point B, then what it will do? Oscillations it will do. Whenever the particle is not able to cross point C, at that time what it will do? Projectile motion, free fall, and then it will follow the projectile path. Now what is that velocity should be? What is the limit of velocity should be? See here velocity is how much to cross the point B? Root 3 gr. If it is less than root 3 gr, at that time what it will do? Oscillations it will do. And also what is that maximum limit to do the oscillation? Obviously it is 1 gr also it will do oscillation only. It is 0.5 gr also it will do oscillation only. But what is the maximum limit? 3 gr means what happens? It will just able to cross point B here. What is that? Less than 3 nothing but exactly how much it will be? Nothing but yesterday you solved already. At what velocity it can just reach point B? You solved that yesterday. Root 2 gr only, right? So that root 2 gr is the last limit. If the velocity is greater than root 2 gr, at that time what happens? Nothing but it can cross point B. From that time what happens? Nothing but it will fall down like this, projectile motion. If the velocity is last limit is 2 gr nothing but it is reaching the point B and then again it is coming back. It is just reaching there. Yesterday I said one problem right before drawing the table. I said in that what is the velocity by which the particle can just reach the point B. In that what is the answer you got? Root 2 gr. By root 2 gr what happening? Nothing but it is just able to reach. That's it. It is not able to cross. It is just able to reach. And it is reaching and then coming back again. Nothing but it is doing what? Oscillations there. Now, whenever the velocity is more than root 2 gr, at that time what happening? Nothing but it will fall down. It will crosses the point B and after that it will fall down. Obviously, projectile motion it will do. So, maximum limit is how much here? Root 2 gr is the maximum limit. If the velocity is more than that, nothing but the particle will cross point B and then it will fall down. Okay. If the velocity is less than that, nothing but obviously it will do oscillation. If less than also it will do oscillation. If it is root 2 gr also it will do oscillation. That is the limit for the oscillation. Then what about the limit for the projectile motion? Maximum limit. Find out that. Find the velocity. Find the velocity of the particle. Find the velocity of the particle to be given at point A. To be given at point A. To be given at point A so that it can just reach point C. 2 into root gr. Root 4 gr. Yes, correct. So it can just reach point C. Find that. Root 4 gr will be the answer. You got that? That is the maximum limit for the projectile motion from there. Got the answer? Root 4 gr is the correct answer. See that at point A I am giving some velocity VA so that it is just able to reach point C, they are saying. So what velocity you have to give at point A, they are asking. For that purpose, whenever I have given a velocity VA here, then this is a 0 potential energy level, obviously 0 level. Now whenever I have given just a velocity VA here, then what happening? Nothing but it is just able to reach point C. I am not asking about it will cross or not. First of all, I am just asking that it can just reach the point C here. For that purpose, generally you have to apply the conservation of energy. I said already yesterday itself, all the problems will be solved based on the conservation of energy only. Energy at point A is equals to energy at point C. Energy at point A, what energy is there at point A? Just kinetic energy is there, potential energy is how much? 0. So that half mVA square, that is what you have to find out. And then at point C, it is just reaching nothing but it is coming to rest there. So what you have to take there? Kinetic energy is how much? 0. Potential energy is how much? mg into, what is the total height here? 2L or 2R, anything is correct only. M gets cancelled here. Then VA square is equals to 4GL. VA is equals to root 4GL. So root 4 GL is the velocity by which it will just able to reach the point C. It is just able to reach, it is not crossing. It has to cross nothing but how much velocity should be there, obviously here. Root 5 GR na generally for to complete the VCM, what is the velocity at point A? Root 5 GR. I am asking the velocity to just reach the point C. Whenever it is reaching the point C, it is not able to go beyond that, means what happens? It will fall down like projectile motion only. So to do the projectile motion, what is the limit of the velocity? Under root 4 GL. To do the oscillation, what is the limit of velocity? Root 2 GL. Clear? Copy that and then write a note point. To oscillate the particle, between ABD the required velocity is required velocity at A is 0 less than VA less than root 2 GL. 0 less than VA less than root 2 GL. Next point. For the projectile motion, of the particle between B and C, the velocity required at point A is under root 2 GL less than VA less than root 5 GL. If it is less than or equal, then what happens? Equal nothing but it will do VCM, it will complete the VCM, but it should be less than 5 GL, nothing but 4 GL also. 4 GL also correct only, but it should be less than root 5 GL. It should be less than root 2 GL here. Why root 2 GL? Nothing but the root 2 GL is a velocity to just required to reach the point B there. So before that what it will do? Nothing but oscillation it will do. Root 5 GL, if it is equals to root 5 GL, nothing but at that time it will complete the VCM. I am saying that less than, so that at that time what it will do? Nothing but it will reach up to point C and then it will fall down. Less than that, for all the values it will do the projectile motion only like this. Clear, right? Yes. Next problem. Write a problem next. Find the minimum velocity required to give to the massless rod at its mean position to complete the VCM. See that I am not giving about the massless string here. What I am giving here? Massless rod. Massless rod is there means This is a rod I have taken, massless rod of length, let me take L. Now here what I am doing, nothing but I have to give some velocity here, so that it will just complete the VCM. So first of all, before telling that is root 5 GR, think what happens whenever I have taken the string. and then I am just rotating in the vertical circular motion. Whenever it is just able to reach the point C, just able to reach, I am not saying that it is crossing the point C, it is just able to reach the point C. At that time what it will do? Can it complete the VCM? At that time little bit velocity I have to give, right? How much velocity? Nothing but root GR I have to give here. So whenever I have taken the string, it cannot complete the VCM by its own. For example, if I take the rod like this only, now what I am doing, nothing but I am just giving enough velocity to go to the top position. At that time, without giving the velocity also, what it will do? It will complete the VCM, right? Understanding or not? So if the point is, the main point is here, whenever you take the string, whenever you take this string only, for example, if this string I have taken, for this string, whenever I have given some velocity like this, then what happening? See that? Projectile motion or not? You are able to assume that? See, it is not falling down, it is falling somehow like this, correct? If the mass is more, nothing but here it will fall down exactly in the projectile motion only. And before point B, what it is doing? Oscillation it is doing. Now whenever this string is just given a velocity to come here, then what happening? It is doing projectile motion. Now it is just able to reach the point C. See that exactly point C, no? Whenever it is able to reach the point C, can it complete the VCM? No. Understand or not? I am giving some enough velocity so that it is just coming here and then stopping here. Whenever it is stopping here, then what happening? It is falling down. It cannot complete the VCM. Why? Because this is a rope only, just that is a string only. If otherwise, if I have taken the pen here, this marker I have taken, this is a rod obviously. Whenever I am giving the enough velocity here for this, the enough velocity to reach the point C, then what happening? It is completing the VCM. Correct? Are you able to assume that? Yes. So that the required minimum velocity should be how much there? What is the minimum velocity should be? Root 5 GL or less than root 5 GL? Think properly. I am saying about the velocity at point A. How much velocity you have to give at point A, so that what happening? Nothing but it is just able to complete the VCM. Just able to complete the VCM, nothing but you have to give the enough velocity to reach the point C. Automatically it will do the VCM. The enough velocity to reach the point C is what? Root 4 GL, no? Just now you find that. So the enough velocity to just reach the point C. After that, whenever I reach the point C like this, I reach the point C, then what happening? Nothing but immediately it will complete. I am not pushing here. You can observe that clearly. See that I am not pushing this one. I am just keeping like this. Then what happening? It is completing the VCM. That might fall in this direction or in this direction. But due to the inertia, obviously it will fall in this direction only. Now I am stopping. Here the possibility is there to fall the right side direction or left side direction. Whenever it is coming from down, at that time obviously it will have inertia, so that what happens? It will fall in this direction only. So that at the topmost point, once it is reached the topmost point, automatically it will do VCM. So what is the velocity required to reach the topmost point? Root 4 GL only, just now we find. So that is very important there. Yes sir. So here again the same procedure, whatever we got before, half m Vs square is equals to mg into, what is the energy here? Mg into 2L is the length here. Again here potential energy is 0 and then here kinetic energy is 0. Then Va is how much we got? Root 4 GL. So here the main thing is you have to write that once the rod is reaching the point C, then automatically it will complete the VCM. If the string is reaching the point C, then what it will do? Can it complete the VCM? It cannot complete the VCM. The string will slack and then it will fall down. Before C, what it will do? Before C, it will do projectile motion. Clear, right? All the points. Whenever the string is just reaching the point C, at that time directly it will fall down only. Whenever the string is just reaching before the point C, at that time what it will do? Projectile motion. The string is reaching before point B, what it will do? Oscillation. If you take the rod, whenever you take the rod, I have taken the rod and then it is just able to reach point B, then what it will do? Nothing but oscillation only. It will come back up to the same position again. Whenever it is just reaching before point C, then what it will do? Any projectile motion for that? No projectile motion, again oscillation only. Yes, sir. Then whenever it is reaching the point C, at that time what happened? Nothing but it is able to complete the VCM. So the minimum velocity is how much here? Under root 4GL. That is the minimum velocity. If the velocity is greater than or equal, at that time it is able to complete the VCM. If the velocity is less than root 4GL, what happens, sir? The rod, what it will do? Oscillation only. No? Less than 4GL, nothing but it is not able to reach point C. Whenever it is not able to reach point C means it will do oscillation only. Clear? Rod ಹೆಂಗೆ ಮಾಡುತ್ತೆ? Rod slack ಆಗಲ್ಲಲ್ಲ. Okay, if it is going like this, nothing but then it cannot fold, no? Then only whenever the string is folding, at that time only projectile motion is happening. Yes, write that. Just copy that answer first of all. And conclusion is very important for this. Kapama. Massless rod. If the rod is having mass, at that time what you have to do? Energy, how much, again how much energy you will get? For this, for example, if I connect the mass here, and also this is a massive rod, at that time how many potential energies you will get? Two potential energies. One is, this one is going here, how much distance it is covering? L distance, here L by 2, here L by 2. This is center of gravity. And this one is going here, at that time it is covering as 2L distance. By the way, for this you put mass here, otherwise how it will go? There is no M only, no? Put mass for that. Write the conclusion first of all. As the particle is connected to the massless rod, if rod once reach point C, then automatically it completes VCM. And before that it will just oscillates. Right, next. Find the minimum velocity of particle. Find minimum velocity of a particle to be given at the bottommost point of a frictionless tube, a frictionless uniform tube. See that here I am taking a small any object here, like ball I have taken. Inside of a frictionless tube you have to do the VCM. Then for that, what is the minimum velocity required here? Think properly and then tell me. Directly you can tell, though there is no need to do the problem, and already we have seen that one is only two choices are there, one is root 5gr, otherwise root 4gr. So from that, which will be the answer for that? It will just come the minimum velocity required, so that it will just complete the VCM. Root 5gr. It is not connected to any string there. Whenever I have given some velocity like this, then automatically it will go and then it will do the VCM there. And this is a frictionless tube, uniform tube. Root 4gr is the answer. See that whenever the tube is not there inside, tube is not there, it is just reaching the point C. At that time what happens? It will fall down, right? If tube is inside, it is not there. For example, I have taken a circular track like that, and then in that I am just doing the VCM. At that time what happening? It is reaching only point C, nothing but automatically what happens? It will fall down, obviously. Before that what it will do? Nothing but it will come back again. And then whenever it is reaching the point C, and due to the inertia what happens? Nothing but little bit, very small velocity will be there. Not small, even velocity also, that is just the inertia only. Once it is reaching the point C, nothing but automatically what happens? It will just move. There is no choice for that. It will come back again. There is a chance for coming back. But due to the motion, inertia is there in this direction, no? It cannot change its direction by itself, inertia of direction. It is not about the inertia of motion, inertia of direction, just direction only. Before and all, it was just moving like this. And if there is no support, nothing, then what happens? Nothing but automatically it will fall in this direction only. But here what happening? There is a support for this. Actually it wanted to fall down, but this inside surface is there, it is not letting it fall down. So what happens? Nothing but once it is reaching the point C, automatically what happens? Nothing but there is no choice, automatically it will fall down in this direction only. So that what happens? It will complete VCM. Clear, right? So what is the minimum velocity required here? Root 4gr. If it is more than root 4gr, nothing but automatically it will complete. There is no problem in that. So that velocity should be either that is equals to, greater than or equals to root 4gr. If it is less than root 4gr, then what happens? It will just do oscillation, it will come back. It will come back and then oscillates like this. So that at this it will complete the, it will just complete the oscillations. At this point it will complete the VCM. Draw the diagram. Diagram is important. Once this one is reached the point C, at that time automatically it will fall in this direction. Like that. By root 4gr velocity at point A, by root 4gr velocity at point A, the particle can just reach point C then automatically it will fall the other side of the tube. It will fall in the other side of the tube, so that it completes VCM. You understand the point, right? What I said? So whenever it is reaching the point C, automatically it will fall down the other side. It is falling down on the other side, nothing but it is completing what? VCM. If it is not having root 4gr, at that time what happens? Nothing but it cannot reach point C, somewhere it will come and then it will fall down in this direction. So here finally conclusion is, for the mass whichever connected to the string and then pendulum, if I take the pendulum, at that time what is the minimum velocity required to complete the VCM at point A? Root 5gr. See that, listen properly, all together all are same only again, so only I am repeating this one. So whenever you take the simple pendulum, for the simple pendulum, what is the velocity to be given at point A to complete the VCM? Nothing but the minimum velocity should be root 5 gr. So that what happening? Nothing but it can reach the point C and it will not fall down, it will just complete the VCM. If it is less than root 5 gr, then what happens? Nothing but it will reach the point C. It will just reach the point C, then what happens? It will fall down. Before that it will do what? Projectile motion, and before this what it will do? Oscillation. That is about the simple pendulum, that is finished. And in this chapter almost all the problems will be based on the pendulum only. Very less problems will be there, not even very less, 5 to 6 problems will be there based on the rod and then this one tube. So that whenever they will specify that is a rod, massless rod of how much length they connected, and then what is the tube radius and all they will give. So that here whenever I take the simple pendulum, the velocity required is how much? Root 5 gr. If I take the tube, inside of the tube if I take the mass, otherwise if I connect the mass for the rod, for that everything, what will be the velocity? Minimum velocity should be root 4 gr. Why? Because once it is reaching the point C, there is no choice for that, it will do the circular motion only, VCM only. There is no other choice for that. Once it is going there, once you are coming here, automatically you have to enter into the class. There is no choice for you, cannot go back to the home again. Understand or not? Once you come there, once you reach the point C, automatically you have to complete the VCM. In case of string, what happens? Nothing but string will become slack. It will get folded and then it will fall down. Why? Because tension will become 0. And also whenever I teach this tension at the point C, I did not say that it is exactly equals to 0. I said that approximately equals to 0. Why it is approximately? Nothing but still the centrifugal force is lying there. It is not 0 there. Centrifugal force is there, automatically little bit also tension will be there. So that the tension is approximately 0. Whenever the tension is exactly 0, then what happens? Nothing but immediately it will fall down. There is no choice for that. So for the string means it can get folded, it can get slacked. So only it will do oscillations, otherwise it will do the projectile motion, otherwise it will fall down directly. But for the rod there is no choice. Once it is reaching the point C means automatically it has to do VCM. For the particle inside of the tube also, once it is reaching the topmost point, nothing but automatically it has to fall down. Due to the inertia, it will just fall down in the other direction. Not in the same direction, it will fall down in the other direction. Clear, right? About the whatever the three bodies we have discussed. One is simple pendulum. Minimum velocity required to complete the VCM is how much? Root 5 gr. For the rod, what is the minimum velocity? Root 4 gr to complete the VCM. For the tube inside of a mass, what is it? Root 4 gr only. Clear, right, everybody? Next we will try next type of problems. Right. I said all of the problem will be based on the conservation of energy only. You have to remember that mainly. Yes. A particle of mass m is tied to a string of massless string of length L, if the particle is given with velocity of root 6 gl at the bottommost point, then find tension at the topmost point. How much velocity they are giving? root 6gl. Anybody will say 0? Is that tension is 0 at that point? Is that 0? What Aishwarya? You said 0 only, no? That is not 0. Whenever at this root 5gl, at that time what happens? Tension is 0. Whenever the bottommost point velocity is root 5gl, at that time what is the tension we got? Tension T is equals to approximately equals to 0 we got. Now they are giving more velocity, no, root 6gl they are giving. Whenever they are giving root 6gl, nothing but automatically centrifugal force also will increases. Why? Because what is the formula for the centrifugal force? mv square by r. This v is increasing, nothing but centrifugal force also increases. Here the topmost point, centrifugal force will act in the upward direction. So that centrifugal force is increasing, nothing but this tension in the string also increasing. Why? Because the centrifugal force is dominating mg here. You understand or not what I said? So whenever here the velocity is given as root 5gl, this is purely logic based. If you are not able to, if you are not having the imagination, thinking and all, then you cannot understand this. Everything you have to imagine. I am saying here is, whenever you have given root 5gl, at that time tension is becoming as how much? 0. Whenever I am giving more velocity, then what happens here? Centrifugal force also increases. At the topmost point, free body diagram of the body is this one. Fc is acting in this direction and the tension is acting in the downward direction. Automatically mg also acting in the downward direction. So at the topmost point, whenever root 5gl is there, at that time we have seen that Fc is equals to directly mg. So only we do not get any tangential acceleration there. But here what happening? Nothing but I am giving more velocity. More velocity, nothing but automatically more centrifugal force. More centrifugal force, nothing but outwards more force is acting. I am pulling the string. Then what happens? Tension will be developed in that. What is that tension will be find out. No? Wrong? Don't say the answers randomly, you have to solve. You have to solve the problem. Don't take the fixed values of velocities and all. Here I have given everything is different. 5 mg. Na? I don't think so. No, you have to solve that. Don't take the velocity as root gl at the topmost point. That is not root gl now. Whenever I have given the, see that people, listen. Whenever I have given only root 5gl, at that time velocity is how much here? Root gl. Now I have given root 6gl here. So the velocity is not that. Velocity will changes. How much? 2 mg na? No. Solve ma, solve. Solve and then say the answer. Don't say that randomly, all of you. Yes, very good. mg is the correct answer. Very good. ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ರಾ ಇದು ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಪೋಯ್ ಮೂಲಕ್ಕೆ ಕೂರ್చున్నావేంట్రా mg is the correct answer. What is the velocity you got at the topmost point first of all? Root 2gr na? Yes. Root 2gr is the velocity at topmost point you will get. Yes, very good. mg should be the correct answer. Uday, water ತಗೊಂಬ ನಮ್ಮ ಬಾಟಲ್ ತಗೊಂಬ How many of you got that? mg is the correct answer. Good, good. Boys, very less. See that here, look at the problem. Whenever the velocity was there, simply by the logic also I will tell. Whenever the velocity was here root 5gl, at that time topmost point velocity is how much? Root gl. Whenever the velocity here 6gl, then what it will be? Root 2gl only, no? Then automatically you know the free body diagram, you can solve the problem. You understand the logic, right? That is correct only, that is correct logic only I said. That is not false, it will be true always. Okay, if I give 8 gl here, then what is the answer here? 3gl, that's it. Okay, now with whatever the value 5gl, nothing but only gl we got here. So that whatever here we are increasing, here also the same amount will be increasing. There you can check by that also, by the way. And also I will tell how it is also. First of all, I said that what is the velocity here? Root 2gl we will get. The velocity is root 2gl at the topmost point. Now take the free body diagram. Here Fc is acting in the radially outward direction. Mg is acting in which direction? Downward direction. And also along with that, tension is acting in the downward direction. So that automatically what you have to take? What you have to take? Fc is equals to T plus mg. So that Fc is equals to T plus mg you have to take. Then T is equals to Fc minus mg. What is Fc here? mvc square by L, L is the radius here, minus mg. So that m into, what is the Vc value here? Root 2gl, na? So that it will be how much? 2gl by L minus mg. Then L gets cancelled. What is the answer for that? mg. T is equals to mg. Now before that, how this root 2gl come, I'll tell. So here you have to apply the conservation of energy. There is no other choice for you. Always you have to apply the conservation of energy. This is a zero level. Then from here to here you have to take the potential energy. So first of all you have to take, let me take point P and then Q. If you take A, B, then you will get confused. Point P and Q I will take. Energy at point P is equals to what I can write? Energy at point Q. Energy at point P is what? Kinetic energy plus potential energy at P is equals to K plus U at Q. What is the kinetic energy at P? Half m into v square. What is the velocity? I said 6gl. So that half m into 6gl plus potential energy is how much? 0. Kinetic energy at topmost point. That is what you have to find out. It did not come yet. I solved before only. So that you have to find out that velocity only. Half m vq square plus what is the potential energy here? mg into 2l. 2mgl. Clear? Now this will be the m gets cancelled here. 6gl is equals to vq square, that plus how much? 4gl. I have taken 2 LCM and then send that side. Then vq square is equals to how much? 6gl minus 4gl is 2gl. Then vq is equals to under root 2gl. So only I got here under root 2gl. Without solving this much also, directly you can solve just whatever the amount you are increasing, the same amount here you have to increase. If I say this is root 10gl, automatically this will be how much? Here how much I increase? 5 times, na? So this also 5 times will be increased, so that how much it will be? Root 6gl it will be. Clear? So with whatever the amount, whatever the count I am increasing the value here. For root gl, with the same count you have to increase. Here before, what is it? To complete the BCM, what is the velocity required here? Root 5gl. How much I increased by? 1. Here how much before velocity was? Root gl. So for that I am just increasing by 1 there also. Then you will get the same answer. For every value it will be correct only. So here first of all, they have given the root 6gl here. Most of the people, before I said the hint, most of you, all of you got wrong answers only. You have taken directly root gl here and then you solve the answer. How much you got at that time? I think this is 0. Tension is 0. Then some of the Medhavi said that 4g and all, 4mg, that and all. 6gl tagandiva. And change agala. It will not at all changes. So see, that answers are wrong. Why? Because here the velocity is changing means here also the velocity will changes. How much amount it is changing here, the same amount it will also changes here. So only you have to apply that logic, and then otherwise you can apply the conservation of energy. So by the conservation of energy at point P and then point Q I have to apply. The energy at point P is how much? Kinetic energy only there, potential energy becomes how much? 0. So that at point Q we have to find out the velocity VQ. For that purpose VQ here I have taken, velocity is VQ, so that kinetic energy is half m VQ square plus potential energy is how much here? It is reaching from 0 level to how much height? 2L height. So the mg into 2L. After that we got VQ how much? Root 2GL. And now you have to take the free body diagram of the body at point Q. Now Fc is acting in the upward direction, mg is automatically acting in which direction? Downward direction. And also inside of the string tension will be developed. So that only T I have taken. And take Fc is equals to T plus mg. And then you got the tension is equals to how much? Mg there. In your options you will be given with a 0 also. So whenever we see the 0 we will get excited. And then we will get negative marks. Clear? Finished? Next problem. If the system is released from the horizontal position, if the system is released from the horizontal position as shown in the figure, find the velocity of the particle, find the velocity of the particle and tension in massless rod at the bottommost point. If the system is released from the horizontal position as shown in the figure, then find the velocity of the particle and tension in the massless rod at the bottommost point. See that here I have taken a massless rod, here massless rod I have taken, I just released. Whenever I am releasing, then what happening? It is coming down. So with what velocity it will come down, and also what is the tension developed in this rod, that is what they are asking. Clear? So the velocity will be automatically in this direction. That velocity you have to find out. Find out that. Don't tell me that that is root 5 gr. Root 2 gr. Yes, very good. Tension? Yes, very good, Nana, very good. Taste different. Tension 2 mg na 3 mg. 3 mg is the tension and the velocity is how much you got? Root 2 gl. I'll explain that. How many of you got that answers? Yes, root 2 gl and then tension is 3 mg. Very good. So here what I am doing nothing but I am just releasing the system. Obviously what you have to do? You have to apply the conservation of energy only. You have to apply the conservation of energy only. First of all, let me take this is a 0 level, otherwise you can take this one also 0 level, there is no problem in that. Anything as 0 level you can consider. I will consider bottommost level only 0 level, and after that here you have to apply, let me take points P and Q again. Between the points P and Q, EP is equals to what you have to do? EQ. At EP, you have to take obviously kinetic energy and potential energy at P, and then kinetic energy and potential energy at point Q. Kinetic energy at point P is how much? I just released. Here diagram I drawn, but diagram will not be there in the problem. They said release nothing but you have to understand that Whenever release, it is u is equals to how much? 0. Automatically u is 0. Kinetic energy also 0 only. Now tell me what is the potential energy of this point here? mg into height only, na? Height is how much height here? Length of the rod only. So that is how much? mg into L before it is falling down. Then after falling down, it is falling at point Q with some velocity. That velocity only I have to find out, half m into v square. What is the potential energy at this point? 0 is the potential energy. That's it, finished. Then v square is equals to what you will get here? V is equals to under root 2gl. That is the velocity I got. Now here finding the tension is different. See that to find out the tension here, centrifugal force will be there in which direction? Downward direction. Fc is there in the downward direction. mg will be there in which direction? Downward direction only. mg also in downward. Tension will be there in the upward direction. So clearly what I can write here? T is equals to mg plus Fc. So mg plus Fc is how much here? mv square by r only, na? So that mv square how much we got? 2 mgl. So that 2 mgl divided by L. Under root v is equals to under root 2gl. Then v square is equals to how much? 2gl. M is there automatically. Then L gets cancelled here. What is the answer here? 3 mg. Clear, right? Next one difficult problem I will give. If point masses, important problem, this one came in the NEET already, previous NEET, I guess 2017 like that, I did not remember the year properly. 2 point masses of M, 2 point masses of M, mass M, connected with a light rod of length 2L, it is free to rotate in vertical circle as shown in the figure. Then find the minimum horizontal velocity. Find the minimum horizontal velocity that should be given at the bottommost point so that it completes VCM. Who filled ink for this? Manoj, nivena? You only? Thousa. See that they have given that how many masses? 2 masses. 2 masses. In that 2 masses, one mass is connected at the end, another mass is connected at the middle. That is the problem. Here 2 masses M and then another is also M only. 2 masses of masses M connected with the light rod of length how much? 2L is the length. Total length of the rod is 2L, nothing but it is connected at what length? L, and then this is also connected at L only. Now you have to find out the minimum velocity to be given here so that it will complete the VCM. By the way, it is rotating with the angular velocity omega. Yeah, nothing is there with omega and all. Just understand what they have given the problem. Previous NEET question, this one is. Little tricky only. Think properly first. Before solving, think what will happen. Anybody got correct answer? For them chocolate. Already nam chocolate namge ಕೊಟ್ಟಿನ ಕೊಡ್ತೀನಿ ಇವತ್ತು ಕೊಡ್ತೀನಿ ಈವ್ನಿಂಗ್ ಸ್ಟಡಿ ಅವರ್ ಇದೆಲ್ಲ Don't say the random answers. I'll give the options for you otherwise. Now tell me the answer. Second option. No, solve. Take it seriously. You can solve this, but try that. Book is there, huh? College material is there. Anybody having college material? Second one. If you get nearby also, tell me the answer. Nearby that values also, you can tell me the answer. Done. Any answer about that? How you got the answer? First of all, velocities of two bodies will be same. Different to yes to you. Very good, very good. So in fourth you got the correct answer only, do it properly. You get the correct answer. That's wrong. Final answer is wrong, but you are doing the procedure is very good. You got the answer almost. Conservation of energy ಚೆನ್ನಾಗಿ apply ಮಾಡು. Slowly apply ಮಾಡು, but you will get the answer there. Velocity is same velocity, different velocity. For two masses, same velocity, different velocity. How they are related? What is that different velocities? two masses will have same velocity or different velocities? Different velocity will be there. They are connected at different places. One is at the end, one is another at the middle. They will have different velocities. Answer करो. But this is MGL. Okay, first one. Okay, fine. Very good. Very good. 3 mg na. ఇలా ఫస్ట్ది మధ్యలోది ఫస్ట్ది అవుదా, దట్ విల్ గో అప్ నథింగ్ బట్ హౌ మచ్ డిస్టెన్స్ ఇట్ విల్ కవరింగ్ ఫ్రమ్ డౌన్ హౌ మచ్ ఇట్ ఈస్. ఎస్ 3 mg. కరెక్ట్ వెరీ గుడ్. సాల్వ్ విల్ గెట్ ద ఆన్సర్. థర్డ్ ఆప్షన్ హౌ మచ్ యూ గాట్ ఎగ్జాక్ట్లీ టెల్ మీ ద ఆన్సర్. యాక్చువల్లీ ఆన్సర్ ఈజ్ నాట్ దేర్ ఇన్ దట్. ఆన్సర్ ఈజ్ 48 GL/5. Actually I have written, instead of 48 I have written as 43, and then I have seen in the mobile and then I was writing 48, so that I thought that you people, whenever I made correction by seeing means you will think that that is the correct option and then you will tell the answer. No, so only I read the wrong answer here. 48 GL/5. 48 only, no 10 GL, nothing. Now you have to tell correct answer, not approximate. Answer is, I am saying here answer is 48 GL/5. That's the correct answer. Uday almost got the answer. Chocolate. Half chocolate. No, I did not say any hint to him. He only solving, papam. Yes, you got that, Uday? I'll give just 1 second time. If you not get, your chocolate will be cancelled. Anybody else? Chocolate gone there. Why you got that is half of the velocity. Tell me the correct reason. Why velocity of the second particle is half. Reason correct reason. Assumption is wrong, but the answer is correct. In NEET it will work out, but not in my class. See the real velocities of the particle. When you started, whenever I said velocities are different, at that time you started, no? Before the tunnel, you was thinking about the velocities are same only. Velocities are different here. How the velocities are different, I will tell. This is NEET problem. Previous NEET problem only, but little difficult. So here I have given omega nothing, but there is something we have to do with omega, no? I said nothing is there, but it is there. Some relation should be there, obviously. Here the meaning is both are moving with the same omega only. Both are rotating with the same omega only. Here whenever I said the masses are connected to the rod, nothing, but at that time these two are rotating with the same omega. That's it. I am giving about, that's it, nothing else. So that here omega given nothing but entire rod is rotating with the omega only. Entire rod is rotating with omega nothing but masses also rotating with omega only. Yes. So that for example, let me take, this is a particle 1 and then this is a particle 2. You have to give the numbers. So here particle 1, let me take the velocity of particle 1 is v1, let me take. v1 is equals to, what is the v formula for us in terms of omega? V is equals to r omega, right? R is how much for this? Whenever it is doing circular motion, whenever the rod is going up, then what happens? Nothing but it will come and then it will do the circular motion like this. And then second particle will do the circular motion like this. You are able to assume that motion? Yes. Now here, whenever this is rotating, nothing but this smaller circle radius is how much here? L is the smaller circle radius. So that L into omega. V1 is equals to L into omega. Then what about the V2? V2 is equals to, whenever it is rotating at that time, what is the radius of that circle? 2L into omega. That's it. So in the place of L omega, what I can substitute here? V2 is equals to 2 times of V1. Then V1 is equals to automatically what I can write? V2 by 2. Understand, right, how it came half? Satvika? Yes. So that here force is applying, long rod is there, so long velocity, here less rod is there, less velocity, that is wrong. Assumption is wrong. So here what happening? Nothing but both are rotating with the same angular velocity omega. So it is doing the circular motion up to only this limit. This one is doing circular motion here. For the smaller circle, what is the radius here automatically? L is the radius and angular velocity is how much? Omega, so that V1 is equals to L omega. And also for the bigger circle, the radius is how much here? L plus L. 2L is the radius and then omega is the angular velocity, so that 2L omega. Then here, in the place of L omega, I can substitute as V1 and then V1 is equals to how much we got? V2 by 2. Now everything is finished. Now we have to do the conservation of energy. So energy initial is equals to energy final. Energy initial for two bodies you have to take. This is a 0 level I will take. Observe properly, in this also confusion will be there. So here this is a 0 level I have taken. Before that it was having how much velocity? V2 velocity. It is having how much velocity? V1 velocity. So that both are having kinetic energies or not? Both are having the kinetic energies. So that what I have to write nothing but K plus U for the first body plus K plus U for the second particle initially is equals to K plus U for the first particle and then K plus U for the second particle finally. You understand the equation what I have written? Two particles are there, automatically two energies will be there. Initially 2 kinetic energies, 2 potential energies, finally also the same thing. So initially kinetic energy of the first one is what? Kinetic energy of the first one is half m into v1 square. So that half m into v1 square. What is the potential energy of the first one? Is that 0? First one is there at some height only already. It is not on the 0 level. It is above the 0 level. How much above is there? L above. So that what I can write? mg into L. First body is finished. Then second body. What is the kinetic energy of the second body? Half m into, what is the velocity there? v2 square plus potential energy is how much? 0. Why? Because this is there on the 0 level only. So that 0 is the potential energy. Then now the m1 is coming here and then m2 is there here. Second particle is there here. Now you tell me what is the kinetic energies of both the bodies? They are coming at topmost point and then they are stopped. So that what happens? Kinetic energy is 0. What about the potential energy of the first particle? What about the potential energy of the first particle? See that first particle is going from where to where? Here to here. Right? From the 0 level, at what height it is? 3L only, na? This is L plus L plus L. 3L. You understand, right, what I said? So after going to the topmost point, what happening? Nothing but this particle is moving from here to here. So that how much here? Length L, L and then L. From the 0 level only you should measure. You should not measure from the initial point. If you measure from the initial point, you will take it as 2L only. But always potential energy nothing but from where you will take ground only, na? So that from the 0 level only you have to consider. So here it is how much here? L is length. Then automatically, what is the total potential energy here? M into G into what is the height here? 3L is the height. Clear, right? You understand that? That is the most confusing point there. Then plus kinetic energy of the second particle also how much? 0. What is the potential energy of the second particle? This one is going from here to here, right? mg into how much length totally? L plus L plus L plus L. Totally how much? 4L. mg into 4L. Understand it? This is 2L before and then this is also 2L. So that how much totally is 4L. Now you will get the answer. Substitute in the place of what is that? Bottommost velocity. No? They are asking to find this velocity only. No? So that V2 you have to find out nothing but in the place of V1 you just substitute V2 by 2. You will get the answer. So half m into V2 by 2 na? V2 by 2 whole square and then write as it is and then you will get the answer. You understand the problem, guys? Right, everybody?